Okay, let's just get this up. Right, so we are now moving on to the next topic, which I think is the fourth topic. Yes, it is. And you will need this booklet. I spoke to you about this yesterday. So some of you have collected it from me already. Some of you are collecting it, and some of you are printing it. If you're not any of those people, will you please get in touch, because you're going to need this. So the next topic is called deformation. And deformation is basically how the crust becomes deformed or changed, and that happens through two processes, which are folding and faulting. So we've talked a bit about these. We've talked a fair bit about these when we did plate tectonics, and when we did earthquakes, particularly for faulting. And at this point, I would just like to say that fold mountains are not just funny; they're hilarious. Do you get it? So mountains aren't just funny, they're hilarious. Just gonna let that sink in. Mountains aren't just funny, they're hilarious. That gets me every time. Right, so what was my point there? I don't know. I just like a good pun. So deformation, folding and faulting. This is what we're going to cover as part of this. I'll get rid of myself now for the moment. What you need to know as part of this. Okay, and as we go through this, you'll realise that we've done quite a bit of this already. So the types of folds and the parts of a fold. How folding has shaped the landscape. So that's mostly fold mountains, and we've talked about that when we've done convergent plate boundaries. Explain what a fault is. We did a lot of that when we talked about earthquakes. Explain and give Irish and international examples of some of the landscapes associated with faults. We've actually done one of those. So one faulting landscape we've done is the East African Rift Valley. So we've done a chunk of that. And describe the landforms created by folding and faulting of the Earth's crust. And again, we talked about the Himalayas and East African Rift Valleys. Anything else? No, that's it. So these are all key words associated with this part of the course. All three plate boundaries are involved: convergent, divergent and transform. Fold mountains formed at convergent. We've talked about fault lines at divergent and East African Rift Valleys. All of this is fueled by convection currents in the crust. So like, you're familiar with all of these, so hopefully doing this topic will just help solidify that information and help you understand it a little bit more. And this is extremely important. Okay, this is on page 3 of your notes. And this is really what I just want you to be understanding by the end of this. Sorry, I'm just messing with the lights here. By the end of this presentation here, and having read through your notes, these are the three processes of deformation. Okay, and you need to be familiar with the language of this. I'm going to read through these with you. So remember, deformation is both folding and faulting. All right, and each of these three processes is associated with a plate boundary. So we're going to start over here. The first process is referred to as compression. All right, and if you compress something, hang on, will I get me back up again? Because I like doing the hand movements. Let's get rid of this. So I'll make me smaller. So if you're compressing something, you're pushing it in. All right, so compression or squeezing. So if you're compressing the crust, you're pushing it in and it's going to fold. That makes sense? You see those folds? And that will lead to folding of the crust. Now, if you keep doing that, eventually the rocks are going to get to a point. Now, they are elastic, so they can be folded, but eventually they'll get to a point where they snap because they can't take it anymore. All right? So compression. Look at the plate boundary it happens at. Let me just disappear myself for a minute. It happens at a... Why can't I draw? Come back. All right, it happens at a convergent plate boundary. So compression at convergent. What happens first is that the crust will be folded. If folding continues and the force of compression continues, then eventually it's going to snap and it's going to lead to faulting. So the process is called compression. It happens at convergent plate boundaries and it causes the crust to fold and eventually fault. Okay. Second process is referred to as extension. Now, sometimes in the books or on the exam papers, they just call it tension. Okay, and if you look at this, the direction of the plates. This happens at a divergent plate boundary. Okay, so at a divergent plate boundary, what's happening? The crust is being stretched or extended. Actually, I have blue tack here. This is good for this. So if you pull apart the rocks of the crust, you see what's happening here? Blue tack thins out and then it will eventually break. So extension, thin, 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 thinner, 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 and then it will snap. Okay, so extension will happen at a divergent plate boundary. The crust is stretched out and it becomes thinner and it eventually leads to faulting. The third process then is shearing, and it's also known as tearing. And this is most associated with transform plate boundaries, although it can happen at convergent. We'll just leave it at transform now to keep it nice and clear. So this is where rocks of the Earth's crust are sliding past each other, and it causes sections of the crust to get caught, and it can eventually lead to faulting. And we did a lot of this when we talked about earthquakes. So really, really important. Page 3 of your notes there. We're going to go through this. So you've got to know the name of the process, you've got to know what it results in, and the plate boundary it's associated with. Only one of them, compression, is associated with both folding and faulting. The other two are just faulting. All right, this comes up a lot of short questions and as part A questions, and you'll see that as we go through the booklet. So page 3. So as the plates of the Earth's crust move towards, away from and past each other, I'm reading from the top, the layers of the rock are changed through the processes of folding and faulting, and these are collectively known as deformation. Keywords that you need to know: fold is a bend in the rocks of the Earth's crust, and a fault is a crack in the crust. Now that's not a very good definition for a fault, and I know you're sitting there thinking, no, that's wrong, because there has to be movement either side of the fault. So if we go back here, you'll see in the fault, this block of land has moved down, this block of land has moved down, these blocks of lands are moving past each other. So it's only a fault line when there's movement of the crust on either side of the fault. So can you please add that to your definition on page 3? So fault equals a crack in the Earth's crust, comma, where there is movement on either side of the crust. No, stop. So a fault equals a crack in the Earth's crust, comma, where there is movement on either side of the fault line. Sorry, where there is movement on either side of the fault line. Okay, I hope that makes sense. All right, now these are just points 1, 2, and 3. I want you to highlight a bit here. So the first one, compression, is associated with convergent plate boundaries. It causes folding of the crust and eventually leads to faulting. So highlight compression, convergent, folding, faulting. Okay, so when you glance at this, you see exactly the name of the process, you see the name of the plate boundary, and you see what it results in. Second one there, extension or tension, associated with divergent plate boundaries. It causes stretching and thinning of the crust and leads to faulting. So you're highlighting extension, divergent, and faulting. Last one there, shearing, is associated with convergent and transform plate boundaries. We're just going to stick with transform for the moment. It causes a section of the Earth's crust to push past each other, and it leads to faulting. Okay, so highlight those keywords there. And I really, really need you to know those diagrams and those words. All right, so moving on to faulting first. This is where we're going to start. So if you take a look at page 4, I'll read through this quickly, then we'll have a look at these images. So folding occurs at convergent plate boundaries where the plates collide, causing the continental plates to buckle into folds. So that's important. It's not the oceanic plate, because what's happened to the oceanic plate? Yes, it has been subducted. Compression. So compression is the name of the process. It occurs at these plate boundaries, and this causes the rocks to wrinkle into folds. And you can see this here very clearly. The crust does not fracture, so that means break, as the collision occurs at depths, and that means deep down into the crust. And here the rocks are subjected to higher temperatures and the plates are more flexible. So basically what this means is that if you think about putting something in a microwave to make it softer, say a Mars bar in a microwave, you heat it up, it's much softer and it's easier to bend. That's what happens to the rocks beneath the surface, because they're closer to the mantle, they're warmer, and they can bend without actually breaking. Another reason why they don't break, so also the process happens gradually over long periods of time, allowing the rocks to adjust to their new position slowly without breaking. Okay, so that's why we can get folds like this, and I'll show you examples of kind of other tighter folds without them actually snapping. Folds can range in size from centimeters to kilometers. It's best seen in sedimentary rocks because the layers are clearly visible. So can you see here? You can see the layers. So these sedimentary rocks the layers would have been horizontal when they were laid down at the bottom of the sea, but folding has now folded them into these shapes here. All right, so that's what folding does. There aren't layers. Strata is the technical word for this. So we can't see strata in sedimentary or igneous rocks. That's why we can't see strata in metamorphic or igneous rocks, but we do see them in sedimentary. A fold is made up of 3 parts: an anticline, syncline, and limbs. I'll come back to those in a minute. And then you have a little section there why do rocks fold. So basically they fold, first point, because of compression. So rocks on the surface are under pressure, and they're under pressure at convergent plate boundaries. They can be folded because beneath the surface of the earth they're exposed to great heat, and the heat combined with the pressure allows them to bend without breaking. But again, if this compression continues and continues, they will eventually fold above surface. Okay, so let's have a look at some folds. Look at these are lovely folds. Look, and they've managed to be folded into these V shapes without actually fracturing or faulting just yet. And this is here just to show you that there are also tiny folds. Actually, do you remember that post I put up at Christmas? There we go here. When I managed to, I think this was on Stevens's day, just before we were trapped in our homes again. And look at these. Oh, why did I zoom out? How do I zoom back in again? Oh, there we go. Look at this. Delighted with this. Look at these lovely folds here in the landscape. Oh, and actually on that same day, hang on, I'm going to go and find this now. It's a lovely sky out there. Sorry now. Put my camera back on so you can see this. I'll make this big so you can see it. Can you see this? No, you can't really see the sky out there. On the same day I took that photograph, I found this. Here it is. Oh. I had to carry this all the way down my backpack, like. Look at that. Isn't that lovely? So up on the batholith, now can we get a bit more light on this? Oh yes. Look at those beautiful folds. And like you can see it here, the shape of it, it's like a U shape. Alright, so absolutely perfect rock to show folding. We've got some layers of quartzite and everything in there. Look at all those minerals in there. Fab. It's like, actually, can I do a smiley face with it? Right, enough messing. Let's leave you down there. Turn me off. Right, let's get back to this. Where was I? Okay, yeah, so folds. Okay, oh look at this, lovely. Now, these are the parts of the fold, and this is gone into your booklets on page 4. Now don't worry about the 3D-ness of it. I don't need you to have that. In fact, I might give you a simpler diagram to see in a minute. But you do need to know that the top part of the fold is referred to as the anticline. The bottom part is referred to as the syncline, and they are connected, so the sides are referred to as the limbs. So basically, if you're out in the mountains, the tops will be the anticlines, the valleys will be the synclines. Can I get up a whiteboard here? Okay, so for that diagram, make them very foldy. You can draw folds like this. Okay, that 2 is probably enough. That looks a bit like the Loch Ness Monster. And you need to have layers. Alright, so I do need to see layers in your diagram. Okay, the top part of the fold, I might just use a different pen for this, is referred to as the anticline. The bottom part of the fold is referred to as the syncline. And the easiest way to remember this is that it sinks down, okay? And then the limbs, I have to write sideways here, are what connects the anticline with the syncline. Sorry now, I'm desperate writing. And you might also just want to label strata. So strata is the word for rock, sugar, layers. Sorry, that's supposed to be what are they called? Layers. Oh my god, I'm actually, I think lockdown is making me slightly brain mushy. What's that called? A bracket. Okay, so that's the diagram that goes on page 4. I'm assuming you can pause it. Right, these are just some layers in the landscape. So you can see the anticlines here, the mountain tops. So we have an anticline here, okay, and here you can see the synclines dipping down. So you can see these massive synclines here in the valleys. Again, a syncline and an anticline on either side of that. Oh, and this is, yeah, we are very blessed in County Dublin to have an example of some excellent chevron folds, which I'll come into in a minute. Do you know where Loch Shinny is? So can you see here, and don't worry, there'll be a close-up of this. Look at that. So this is exposed on a cliff top in County Dublin, which you can all go and visit once they lift the 5k and we're back to inter-county. In fact, I will expect a selfie from all of you. Nice boulder clay cliff up here, caused by glaciation, but let's not bother with that for the moment. Now, look at this close up. You can see the layers, okay, in the folds and the chevron folds. And it's limestone, and again, limestone is sedimentary rock, so you can see all the layers. There I am. I visited it before we were restricted. But luckily for you, so here is Loch Shinny, okay? You can get to 33 from Lower Abbey Street. So this needs to be a little excursion for you once we're allowed to leave the 5k. I want you to go out, get to 33, take a picnic, lovely coastal location there. And in spring you'll get a nice bit of weather. You can sit there, you can look at the constructive and destructive waste, so much geography, take a picture, post it to the page. That would make my day. Right, and that is all we're going to do for today. Get rid of me. So I just want you to read through pages 3 and 4, make sure you understand that, and also we're going to try get used to using the class notebook. So what I want you to do is, and I'm going to show you this now, I'm pink because there's a lovely sunset there at the moment. Let me get out of this. Okay, so I've put the K, you know the way we always do the KWL, probably should have done that at the start. So I put the KWL that's in your booklets into your class notebook. Alright, so I just want you to get used to using this. It's a small task, and like I said, the main problem with this is that it doesn't give you notifications. So I'm just going to scroll down here to test students. So in your homework and task section, okay, if you click on that, you'll see that there's a page there called KWL Folding and Faulting, and if you click on that, you'll see that the table is put in there. There's also instructions. This was kind of just me playing with it. You don't really need to listen to that. So basically what you need to do is type into the KWL. Oh, you can get rid of that by just going to, I don't know, oh, there we go. Control underline. So I don't need it underlined, I don't need it bolded. So I want you to fill out the KWL, not the L part. So what you know already about folding and faulting, what you want to know about it, and then we'll come back and do this afterwards. And I just want you to get used to using OneNote or a class notebook or whatever you're using it for. Is that okay? So I want you to fill out the KWL. I'm going to put up a short assignment on Teams, but only do the assignment after you've learned that table on page 3, because I really want to test that you're comfortable with compression, extension and shearing. And that is our brief introduction to deformation. Goodbye.